So, what is organic chemistry? So, before we move ahead with organic chemistry, first of all, tell me, you must have heard of these terms: organic lifestyle, organic crops, organic rice, organic vegetables, organic fruits. So, what does organic word mean? Organic means anything that is natural. So, natural form of anything is called organic. Now, in chemistry, organic chemistry is the study of compounds of carbon. So, compounds of carbon are called as organic compounds and their study is known as organic chemistry. So, we have representation of organic chemistry compounds in three formats. One is the complete structure, next is condensed form, and the third one is bond-line structure. Similarly, three-dimensional representation could be done in a dash and wedge structure. You can call that as flying wedge also. Now, why does so many organic compounds or carbon compounds are found in nature? So that is a beautiful question. Why we have so many carbon compounds? So the reason behind that is carbon has a unique property to form multiple bonds. Multiple bonds? How many? 4 bonds each carbon atom is forming. So covalency or the number of covalent bonds formed by one atom of carbon is 4. So it is called tetravalent. Carbon atom is called as tetravalent because each carbon atom forms 1, 2, 3, 4 bonds. Alright. Now, next unique property about carbon is it has a catenation property. What is catenation? Catenation is self-linking of atoms, with each other to form long carbon chains. So, self-linking of atoms of carbon to form long carbon chains is known as catenation. Due to these two properties, good catenation, that is formation of long chains of carbon atoms, and second is tetravalency. Due to these two features, carbon is forming lots and lots of compounds. So, we have a separate branch of chemistry that is called organic chemistry. Now, how to represent a molecule? I will show you how we can represent a molecule. We can represent any molecule in different ways. For example, if I take pentane. So, pentane has a formula C5H12. Now, you can represent the structure of this compound like this. We have 5 carbons, so you can take 5 carbons which will be connected to each other like this. Each carbon must have 4 bonds. So, one bond of this carbon is formed between the other carbon, other remaining bonds are formed with hydrogen. Next, these 2 bonds this carbon has and the additional bonds are formed with hydrogen. These bonds are formed with hydrogen. So, this is complete structure of pentane. Complete structure of pentane you have in front of you. All the bonds I have shown over here. Now, if I do not want to represent the complete structure, what I will do? I will represent the carbon-carbon bond and carbon-hydrogen bonds I will not. So, how I will write? Just remember one thing always while writing structures, that each carbon atom must form 4 bonds. As this carbon, if I am checking this carbon, so it has formed 1 bond with this carbon, so remaining 3 bonds are formed with hydrogen. Similarly, this carbon, if I am checking this carbon has formed 2 bonds with adjacent carbons, so remaining 2 bonds are formed with hydrogen. So, additional bonds are formed with hydrogen. Alright. So, each carbon atom you can check out in this structure, each carbon atom must have 4 covalent bonds. Alright. Now, if I want to represent this in a less space, I will use a condensed structure formula that could be written like this: CH3, CH2, CH3, CH2, CH2, CH2 and CH3. Or what I can do is I can remove this carbon-carbon bond. This is a complete structure, this is condensed structure, and I can write it like this also: CH2, CH2, CH2 and CH3. So, these are few representation methods for writing structures. This is a complete structure, these are condensed structure. There is semi-condensed and there is completely condensed structure. Now, if I use bond line structure, what is bond line structure? In a bond line structure, what we do is we do not show carbon and hydrogen atoms. What? We do not show carbon hydrogen? Yes, we do not show carbon and hydrogen atoms. So what do we show? We show just carbon-carbon bonds. For example, if we have pentane, we will represent it like this: 1, 2, 3, 4 and 5. This is pentane. Interesting, right? This is very interesting representation, and bond line structure is a zigzag representation. I'll show you how to interpret this. You can interpret like this: there will be carbon atom at each junction. There will be one carbon at the start and one carbon at end of each line. I'm repeating it for you. One carbon at the start of line and one carbon at the end of line, and one at each junction, and each carbon must have 4 bonds. Let's see. So I have a carbon out here, one carbon here, one carbon here, one carbon here. I'm just showing this structure, this bond line structure. What does this mean? This means at each bend structure, starting we have carbon, at the end we have carbon, at each bend structure or at the junction we have carbon, and each carbon must have 4 bonds. So one bond is formed between carbon, remaining 3 bonds are formed with hydrogen, and remaining 2 bonds are formed with hydrogen. Remaining 2 bonds are found with hydrogen. So each carbon must have in total 4 bonds. So this structure means the pentane. If I stretch it like this, you will see the structure prior to this we have studied. Now there is a dash and wedge representation which has been shown out here in the figure. Here the solid bond and dash bond. This tells us a solid bond means a bond is coming outside or towards the observer, and a dash bond means away from the observer. Dash bond is away from observer, solid bond means towards you, and dash bond behind the board or behind your book. So solid bond is like this, towards upwards, and dash bond is downwards, right? So this is 3D representation. Next we have 3 categories of compounds. One is alkane, another is alkene, and third one is alkyne. Alkanes have carbon-carbon single bond, alkenes have at least one double bond present, and alkynes must have triple bond, at least one out of many. Alright, and what are the hybridization? Hybridization of alkane carbon is sp3, alkene carbon is sp2, and alkyne carbon is sp. And we are talking about the double and triple bond in alkene and alkynes. So this is it for now. Thank you.